Welcome. In this lecture, we would understand one of the very important non-parametric tests, and that is Kruskal-Wallis test. Now, Kruskal-Wallis test is an interesting test. Why? Firstly, because it is a non-parametric test. So, it is applicable only on the studies where the distribution is not normal. So, in the case of distribution being non-normal or not normal, we would apply the concept of Kruskal-Wallis. This Kruskal-Wallis is an equivalent form of ANOVA. What is the major difference? ANOVA is a parametric test, that means it is applied where the distribution is normally, where the values are normally distributed. However, Kruskal-Wallis is a non-parametric test applied where the values are not normally distributed. In both of the cases, there should be 3 or more independent samples. Very important. When we talk about Friedman test, we use dependent samples. However, here the samples are independent. So none of the values in this and this match. So when we talk about ANOVA, we take the difference of means. So of this value, what would be the mean value? That would be taken. Of this value, what would be the mean value? That would be taken. And the same for all the 3 groups independently. However, when we are talking about the Kruskal-Wallis test, we assign the ranks. Now these ranks are interesting. In Kruskal-Wallis, so Kruskal-Wallis is difference of ranks and sum of ranks, right? Now, when we assign the rank in Kruskal-Wallis, what is unique? The smallest value is assigned rank 1. In contrast to this, when we are talking about Friedman test, the highest value is assigned the rank 1. So let's say within all of these have different values. Okay, so the smallest value would have rank 1, rank 2, rank 3, then again 4, 5, 6 from this group only, then 7, 8 from this group, 9 from this group, 10 again from this group, and so on and so forth. What we do is, then we take each of these groups and sum their ranks. So I take the total of all the ranks which is given in the first group, all the ranks in the second group, and all the ranks in the third group. Now, one very important thing, assume that some of the ranks are common. So let's say some of the values they attain are common. For example, this person that gets 20 and this person gets 20. Against 20, this person is having a rank 4 and this is again on rank 4. So what we would do is, so this should be either on 4 or 5. So both of them would be given rank 4.5. This is what is called as tie. Now it's important. This tie value could be different in different groups. So this 4.5 value could be in group A and then it could be in group C. So it's again important to note how the tie values work. However, with the tie values, the H value which we are calculating for the Kruskal-Wallis would not change a lot. There would be minor changes only, but still we need to understand how and why we do so. Now, what is the null hypothesis? The null hypothesis in the case of Kruskal-Wallis is very